Hello everyone. This video is about section 3.3. We're going to practice computing the slopes of lines, sketching the graphs of linear equations, and we'll work with all three forms for linear equations: the slope-intercept form, the point-slope form, and the general form. Recall that if you have a line that is not parallel to the y-axis and you have 2 points on the line, then you can compute the slope of the line by finding the change in y and the change in x and taking that ratio. So the slope m is y2 minus y1 over x2 minus x1. The slope-intercept form, which students are most comfortable with, looks like y equals mx plus b, where m is the slope and b is the y-intercept, or more appropriately, the point 0b is the y-intercept. The point-slope form, which I found to be more useful, looks like y minus y1 equals m times x minus x1, where m is again the slope and the point x1, y1 is on the line. And then there's also a general form, ax plus by is equal to c, where a, b, and c are real numbers. That form is more useful when it comes to generalizing lines to other kinds of shapes. And we'll work with all three of those forms in this video. First problem here, we want to find the general form of an equation for the line through the point -1, 4 that has slope 2/5, and we also want to sketch its graph. Now, using our point-slope form looks like y minus y1 is equal to m times x minus x1, where again m is the slope. Well, they gave us the slope here is 2/5, and they gave us our line, our point on the line. x1 is -1. This is the point that's given to us. And y1 is 4. And so we just got to plug and chug here. I guess that's the initial step. Do y minus 4 is equal to 2/5 times x minus a -1. And then we need to express this in general form. The general form is ax plus by is equal to c. Now, unlike slope-intercept form and point-slope form, where there's really only one correct answer, there are technically infinitely many correct answers here, but there is one that is preferred in our class. So the way that we're going to proceed here is we're first going to get rid of this fraction by multiplying on both sides of this equation by 5. And when we do that, we'll get 5y minus 20 is equal to 2 times x plus 1. I'll go ahead and simplify the expression inside the parentheses. When I distribute the 2, you get 2x plus 2. Then to get general form, we need all of our variables on one side and all of our constant expressions on the other. So we'll go ahead and bring the 2x over to the left-hand side, leave the 5y over there, and then bring the 20 over to the right-hand side. So we'll have 22 on the right-hand side when we add 20 to both sides. Now, like I said, this is a correct answer. In Math 136, the preferred answer is, first we prefer a to be positive. We want the coefficient on the x term to be the positive one. Or I guess it could also be 0. All right, so I guess if we want our x coefficient here to be positive, we'll need to multiply on both sides by -1. So we'll get 2x minus 5y is equal to -22. And then the other feature that we want is we want there to be no common factors among a, b, and c. i.e., we don't want to be able to factor something out and cancel. And then I guess the third thing I didn't think of, we want a, b, and c A, B, and C to be integers. Right, and that's exactly what we have here. We have A is positive, A, B, and C are all integers, they're whole numbers. And, well, while it is true that A and C share a common factor of 2, B doesn't share that factor. So we want the common factors to be for all 3 numbers. So anyways, the boxed answer is going to be my final answer here. Now, when it comes to graphing the line, this is where, well, we didn't really need this information to graph the line. We know that the point -1, 4 is going to be on our line. So that's one point. For any line, we just need 2 points. And so that's 1 point. And then we could find a second point by remembering that our slope is change in y over change in x. So if I go up 2, that's the change in y, and to the right 5, there's 1, 2, 3, 4, 5. That'll get me to a second point on our graph, and then we can draw the line between those 2 points. And if we wanted to graph a few more points just to make sure that we got our line drawn straight, we could do that as well. All right, now, obviously the arrows here are not part of the graph. It's the line itself that is the graph. All right, so that's how we sketch the graph. Given a point and the slope, that's how we would sketch the graph for this equation. Now, I think our x-intercept is maybe a little bit too far out to see on the graph, but we could compute it, and we could also compute the y-intercept. The problem doesn't ask us to do that, but let's go ahead and do that. So remember, the y-intercept is the point on the y-axis where the graph crosses, and that corresponds, well, the y-intercept has coordinate 0b. Now that's a different b than this b, by the way. This b right here is a different b than this b over here. All right, so don't confuse the point that we're using the letter b in 2 different spots here. But I guess the point here is that the x-coordinate of the y-intercept is 0. And so when we want to find the y-intercept, we're going to take any one of these equations. I'm going to take the one that we ended up with and plug in x equals 0. So 2 times 0 minus 5y is equal to -22. The first term here is 0, and so we have -5y is 22, and if I divide on both sides by 5, I get y is 22 over 5. Or that is the same as the decimal 4.4. So that's our y-intercept, or I guess if we wanted a coordinate expression, or sorry, a coordinate pair, our y-intercept would be the point 0, 4.4. 4.4 in this case is an exact decimal representation. The x-intercept, on the other hand, well, that's some point a0. Again, a is different, means something different here than it does back up here. The key thing here is that the y-coordinate is 0, and so we're going to take our equation and plug in 0 for y and solve for x. And when we do that, the y term goes away. We have 2x is equal to -22, and we divide on both sides, we get x is -11. So our x-intercept is -11, 0 as a coordinate pair. So we were just off the graph over here. All right, I think we've done everything that the question asked, plus a little bit more, so let's move on to the next one. Find the general form of an equation of the line through the point -1, 6 with x-intercept 5 and sketch its graph. So in the previous problem, we were given a point and the slope. Here we're given 2 points. 2 points. The x-intercept, now our book follows it just gives numbers for x-intercepts and y-intercepts. The Math 136 coordinators prefer us to write these things as coordinate pairs. So the x-intercept here as a coordinate pair would be the point 5, 0. And now we can use these 2 points. Now if we had a point and the slope, we could use the point slope form. Unfortunately, they didn't give us a slope. However, we can compute the slope. Remember, the slope is y2 minus y1 over x2 minus x1. So anytime we have 2 points, we can always compute the slope. So let's pick one of these points and call it point 1. I'll just take the first one and call it point 1. So we have x1, y1 here. And the second point will be x2, y2. So when I plug the values in, I have y2, which is 0, minus y1, which is 6, all over x2, which is 5, minus x1 is negative 1. So that gives us negative 6 over 6, which is negative 1. So now we have our slope. Sorry, this should be the slope, not y. This should be the slope. So now we have our slope, and we actually have 2 points to choose from. We have 2 points to choose from. I think the x-intercept will be easier to work with. And so I'll take y minus 0 is the y-coordinate of our point that we're going to use, is equal to our slope, negative 1, times x minus the x-coordinate here is 5. So we get y is equal to negative x plus 5. That actually looks like slope-intercept form there, doesn't it? But they want the general form. They want the general form. So we want our x's and y's on one side. So I'll bring the x over to the left. And it turns out that when I do that, everything works out the way that we want. Our x coefficient is positive. There's nothing that can be factored out. And all of our a, b's, and c's are whole numbers. So there's the general form. When we go to sketch its graph, I'm just going to go ahead and use this form right here. That is slope-intercept. Our slope is negative 1. And our y-intercept is the point 0, 5. All right, so we have, actually, when it goes to graph, we have 2 points. Why am I going to all this trouble? That was silly. We have 2 points already. So it seems a little bit silly. We have the point negative 1, 6, which we can graph. Sorry, that's negative 1, negative 6. Point negative 1, 6 is up here. Negative 1, 6. And then we also have the x-intercept. And I can sketch the line through those points. So we didn't necessarily even need to refer to the slope-intercept form to get this graph drawn. But we can identify our x and y intercepts here. They're obvious enough where I don't feel the need to spend any more time. We actually have already identified them. So let's move on to the next problem. Here we want to find the slope-intercept form. So that's the y equals mx plus b. That's the slope-intercept form. Our line has x-intercept negative 6. Let's write that as a coordinate pair. Y-intercept negative 1. That's the point 0, negative 1. And sketch its graph. We already have both of these points. We might as well sketch the graph. We have negative 6, 0, and 0, negative 1. And I'm going to go ahead and plot a third point. I can see, well, no, we'll save that. We'll save that for a different computation here. That's kind of a crappy line, but we get the idea. So we got the graph here. It's not the prettiest graph ever, but we're okay with it. Now we want to find slope-intercept form. We know the y-intercept. So we know that b is going to be negative 1. And so now all we have to do is compute the slope. The slope will be y2 minus y1 over x2 minus x1. Change in y over change in x. And let's see, we gotta give names to our points, so we'll call the y-intercept the second point since it was given second, x2, y2. And the x-intercept's our first point, x1, y1. Doesn't really matter. It doesn't matter which one we call the first point, which one we call the second. What really matters is we gotta make sure that whatever the first numbers on top and bottom, they correspond to the same point. So that's another way to think about this. -1, you can kind of build your fraction piece by piece. -1 over 0. And then this y1, x1 is 0 and -6. So then our slope here will be -1 over 6, or -1/6. So when we go to give the slope-intercept form, this is a plug and chug now. Y is mx, so -1/6 x plus b plus a -1. Or we would usually simplify this to 1/6 x minus 1. All right, and that's all we have to do for this one. Now, if we wanted the general form, I would, well, here's the thing, is if I just added the x business to both sides, we'd have 1/6 x plus y is equal to -1. And that's technically of the form ax plus by is equal to c. But we prefer whole numbers, and so, well, I need to multiply on both sides by 6, and I get x plus 6y is -6. And now we have all of our coefficients are whole numbers. And there are no common factors that I can factor out. And the x coefficient is positive. One last example here. Find the slope-intercept form of an equation of the line through points -3, 1, and 2, 7, and sketch its graph. Again, we already have the points, so we can go ahead and plot these. -3, 1, 2, 7, and draw the line between those 2 points. That one's a little bit better than the last one. Let's go ahead and find the slope-intercept form. Now, unlike the last problem, we weren't given the intercept. And so I think it's best to start with the point-slope form and then rearrange that equation to give slope-intercept. So we're initially going to use y minus y1 is m times x minus x1. We need to find the slope. Slope is change in y over change in x, which is, like I said, it doesn't matter which point we call which, but we just got to be consistent on top and bottom. So I need the y-coordinate from, I'm going to take this to be my second point, the y-coordinate from that point and the x-coordinate from that point, and then the y-coordinate from the A point and the x-coordinate from the A point. We get 6 on top and 5 on the bottom. So our slope is 6/5. And now I'll just use, since there really is no preference, I'm going to go ahead and use the A point as my x1, y1 in my point slope form. So y minus the y-coordinate of that point is the slope, 6/5, times x minus the x-coordinate of that same point. Again, the point doesn't matter, but the consistency does. All right, so there's a good point-slope form. Y minus 1 is equal to that. Now to get to slope-intercept, we're going to have to first distribute the 6/5. So 6/5 x plus 18/5 when I multiply 6/5 by 3. And adding 1 to both sides, y is 6/5 x plus 18/5 plus, I'm going to call it 5/5. 1 is 5/5 when I get a common denominator. And adding those two terms together, 6/5 x plus 23/5. So there is our slope-intercept form for this line. Again, the problem doesn't ask us for general form, but we could find general form by multiplying on both sides by 5 first to get rid of fractions. 5y is equal to 6x plus 23. And then bring the x part over with the y. Negative 6x plus 5y is equal to 23. This is a perfectly fine general form, but again, in Math 136, we usually like our x coefficient to be positive, just so that everybody's answer is consistent, is really what this is all about. And there are no common factors between 6, 5, and 23, and so there would be the preferred answer. All right, so we have several examples here working with the different forms of the equation for lines and graphing lines. Again, when it comes down to graphing lines, you just need 2 points. And if you're given 2 points, you can work with those 2 points. We don't, in previous classes, there maybe have been an overemphasis on this y-intercept, but we don't need to emphasize those things here. However, I guess that just brings up something. We can find the y and x intercepts here. I guess they're interesting. So let's practice that. The y-intercept would be the point where the x coordinate is 0. So I'm actually going to take my general form. General form is good for finding intercepts, by the way. So we got 6 times 0 minus 5y is equal to negative 23. The 6 times 0 term goes away, so we have negative 5y is equal to negative 23. If we divide on both sides by negative 5, we get y is 23 over 5. So our y-intercept is the point 0, 23/5, which is a little bit less than 5. It's 4.8 if you write it as a decimal. Sorry, 4.6 if you write it as a decimal. And if we want to find the x-intercept, that is the point where the y-coordinate is 0. Our x-intercept is over here. The y-coordinate of that point is 0 if it's on the x-axis. So we're going to plug in 0 for y. 6x minus 5 times 0 is equal to negative 23. That business is 0. And when you divide on both sides by 6, you get x is negative 23/6, which does not have a nice decimal expansion, but it's a little bit less. It's a little bit less than 4. So my picture here isn't super great. Well, it's a little bit more than. Sorry, it's a little bit more than negative 4. It's greater than negative 4. So it's to the right of negative 4. The coordinates of that point would be negative 23/6, 0. Okay, that's all I wanted to talk about in this video. I hope it was helpful.